Hello, everyone. Good afternoon, and welcome to Virtual Planetarium, the sky tonight, part of our MOS at Home programming. My name is Janine. My pronouns are she and her, and I'll be your moderator today. That means that I'll be reading some of your questions and responses, which you can submit below using the Q&A button at the bottom of your screen here in the Zoom meeting. If you'd like to see captions during today's program, you can click on the closed captions button at the bottom of your screen and select show subtitles. And if you're joining us on Facebook or YouTube, hello! Thank you so much for joining us today. We're so excited you're here, but unfortunately, I'm unable to see your responses at this time. Thanks everyone for joining us. Let's meet our guide for today.
Well, hello there, and my name is Chuck. I use he, him pronouns, and I'm going to be taking you through a tour of the night sky, explaining what you could see in the sky tonight or on the next clear night, and we'll actually be taking a look at some events in the near future, how the sky is going to be changing over the next couple of weeks, and new things that you'll be able to see in the sky. So we'll take you through a whole night here and show you, of course, those old-fashioned star patterns, the constellations. We'll tell you a little bit about that as well. So I am now going to bring up a piece of software which we'll use to guide us through the night sky. And this is a piece of software called Stellarium. It is one of a number of freeware or shareware programs that you can get for your computer. You can also get a number of apps such as Sky Safari and so forth. That actually are desktop planetarium programs that can simulate on your screen what it's like to be under the real night sky or in a planetarium. And by the way, our museum is open. The planetarium is now open once again for the public, giving its shows. But for live constellation talks, you've come to the right place here on Virtual Planetarium, the sky tonight. So we're looking at a sky just around sunset, but not sunset today. I'm showing you sunset on the or about the earliest sunset of the entire year, and that was back in December. I'm sure everybody has noticed that the sunsets are getting later and later. We've got a little bit more daylight every day, and it's actually accumulated to quite a bit more daylight now in the late afternoons, whereas the sun set at about a little after 4 o'clock on its earliest. I'm going to go down here to the date and time window and move dates ahead. And this is about 3:45 in the afternoon as the sun is about to set. Let me just show you the difference that's accumulated in the last 6-7 weeks or so. So at about 3:45, the sun was very low on the horizon. But since then, ignore that moon that just went by. It's the fastest moving thing in the sky. Since then, I'm advancing the dates ahead into the new year through January. And now at 3:45, we are 9, 10, 11th, 12th today. The sun is considerably above the horizon. So instead of being just about to set at 4 o'clock, now the sun is still above the horizon at 5 o'clock. So here we are, 4:45, and the sun's still above the horizon. That is the the sign of the ending of the winter season and the beginning in just a little bit of a month over the spring season that will be starting. So since we are now on today's date, I'm going to go ahead and move time ahead a bunch of minutes here. Watch the sunset, watch the sky slowly darken, and the moon is in the evening sky, just barely. So here we are at about 5:40 or so. If it were clear tonight, it hopefully is clear where you are and are tuning into this program. It is not clear here in Boston. But what I like to do is to zoom in a little bit and zoom in on a very, very thin fingernail moon that you will see. Now, the moon, of course, goes around the Earth, and about once a month, it passes between the Earth and the sun, almost in a line, but not exactly usually. And during that time, we have the new moon, and we had a new moon yesterday at about 2:30 in the afternoon was the moment. when the moon, sun, and Earth were in line, the moon was almost directly between the Earth and the sun. And then, of course, you can't see it. You can't see it because it's lost in the glare of the sun, and you also can't see it because the only side of the moon that is facing you is dark. It's getting no sunlight. But it's when the moon sets tonight will be about a day and 3 hours after that, and that is just enough for trained observers. If you have a very, very clear western horizon, and actually those folks on the West Coast are actually going to have a great view of this because the moon will have moved another 3 hours. In its orbit by the time folks on the West Coast have sunset. And also you've got the Pacific Ocean. You've got a very flat western horizon there. And you should be able to see a very, very thin, I'm indicating it with the arrow here, a little bit of sunlight peeking around the corner. Now the moon's going to be very low, and it will set at about 5:45 in the Eastern time here. But I'm going to zoom out a little bit. And if you can't see it tonight, it's a real challenge. There's often a challenge afoot among astronomers to see how few hours after the time of new moon that the astronomer can see that little bit of a thin fingernail moon. But you can see it tomorrow night also. So let's move ahead time a little bit to tomorrow night. So what happened? The moon moved in its orbit. It moved about 12 degrees of angle, or about 1/30th of the way around the Earth, because don't forget it takes 1 month for the moon to move around the Earth. And so what happened? You can see a little bit more light on the side of the Earth, a moon facing the Earth. And you can also see the dark side. Now that you think about that for a second, you can see, and I'm going to put this as a question, and you can chat in if you like to try to answer this question. You can see the sun, where the sunlight is shining, of course, on the moon, but there's no sunlight shining on this side of the moon. It's the side facing away from the sun. It should be dark. Where do you think this light is coming from? It's a faint, ghostly light that you'll see when you have a very thin crescent moon. Where do you think about that for a second. Where do you think that light is coming from if there's no sun on that side? Excuse me.
And we have a couple answers coming in. Yeah. So Becky says it's maybe from the Earth. Regina and Natalie are both saying maybe it reflects off the Earth. And Chloe says maybe the sun.
These are all good answers. And in fact, it is coming from the Earth. Chloe answered it is the sun, but it is the sun indirectly, the sun reflecting off the Earth. This is a phenomenon sometimes called earthshine. And earthshine is simply when you have the sunlight shining on the Earth, bouncing off it and bouncing out to the moon. And so much light is bouncing off the Earth that it's actually lighting up the surface of the moon. And think if you were on the moon at this time, this exact moment, you were standing on the moon and that night side, what would you see really big and bright in the sky? You'd see the Earth, and the Earth full and almost full Earth, looking about 80 times as bright as the full moon. You could read your newspaper by the light of the almost full Earth. So it's bright enough to light up the whole landscape around you. That's why we can see it here on Earth as Earthshine. So you can see that for a couple of days until the question has become, until the moon has moved farther and farther away. So let me zoom out a little bit, show you what's going to be happening to the moon. I want to zoom out too far. Over the next few days. So I showed you the moon where it's going to be tomorrow night. This is where this moon is going to be the night after that, and the night after that, and so on. And so we're exaggerating the Earth shine here in this particular view. It's gone pretty much, but you can also notice the crescent is getting wider and wider. Okay, so let's go ahead and move time ahead a little bit to 6:40, 7:40 after dinner, and see what is in the sky in terms of stars and planets for our night sky view. So opposite the sun in the sky, in the eastern and actually southeastern part of the sky, are the glorious constellations of the winter circle. And so let's zoom out here so we get a nice wide view. At the bottom of your screen here, the letters, the red letters SE and S and SW indicate direction. So we're seeing what direction we are looking in. It's always important to know what direction to find things in the sky. So after it gets dark, actually, I'm going to back things off to about 6:45 or so tonight. So in the southeastern sky, southern sky, coming up there, you have fairly bright stars. Does anybody notice 3 stars close together? 3 stars in a line close together, and you may know what this is. So if you see 3 stars in a line very close together and can identify that, put it in the chat. So we have Orion, and that is in fact, or Orion's belt, and that is in fact what is. This is the constellation of Orion, and there it is there. In mythology, it represents a hunter, and somewhat like this, a hunter in ancient Greek mythology. Let's zoom in a little bit more so we can see that. And 2 stars mark his shoulders. There's one called Betelgeuse. That is an Arabic name meaning shoulder of the Great One. That is Betelgeuse. And then another one marking that marks his right shoulder. Here's his left shoulder. Here's his tiny pinhead up here. 3 stars very close together on his head. His belt. 2 more stars locate the hunter's legs, including Rigel, which is a star almost as bright as Betelgeuse or Betelgeuse. There are several ways of pronouncing that name, so don't worry about getting the correct one. It's a foreign name. Many of these star names are from Greek, Roman, Arabic sources, so they may sound a little strange to our ears, but they should also sound familiar to us because they're the brightest stars, and they've been in the sky all of your lifetime. So Betelgeuse or Betelgeuse and Rigel, compare the 2 of these. If you can see a difference between these 2 stars, put it in the question and answer box, put it in your chat box and see if you have an idea what the difference is between the stars and why that difference is there. One is bigger. Yeah, actually, they both about look the same brightness. They are different in size, but you can't see that fact by just looking through a telescope or even with your eye. Betelgeuse looks bigger. Well, maybe. Is there a? I'm going to zoom in a little more so you can see that, and I'm going to get rid of that line. So Betelgeuse and Rigel. Do you notice it didn't another different? Somebody said one looks blue and one looks orange. There is a difference in color. Why would there be a difference in color between stars? What does the star's color tell you about the star? If you have an idea, go ahead and put it in the Q&A. One says age of the star. And another said, because it will die soon. Maybe you remember last year, a little bit more than a year ago, there was possible discussion that Betelgeuse may die violently as a supernova soon. Maybe, we don't know. The gas, maybe the age of the star. Another good guesses as well. Somebody said temperature, Max said temperature, because one is hotter than the other. Andrew also said that as well. A star's color tells its temperature. So the redder a star is, you might think red is the hot color. Well, it's the other way around. The bluer a star is, the hotter it is. The redder a star is, the cooler it is. Betelgeuse has a surface temperature about half the temperature of the sun. And Rigel has a surface temperature over many times hotter than the sun, maybe 9 times as hot as the sun. So blue stars are really, really, really hot. A lot of people said chemical. A lot of people said what the chemistry of the star is, what kind of gases it's made of. Some things have a color that could be used to tell the temperature. It could be used to tell the chemical composition of the gas. But in this case, what it's really telling us is the temperature of the star. In the case of nebulas, you can tell if it's hydrogen gas, if it's got a red light and so forth. Now, this is a different thing going on here. So that is Orion. We'll put its lines back up there. Orion is in the center of what we call the winter circle of stars. A very great group of stars that is visible during the wintertime season. And near Orion is the brightest star in the nighttime sky. To the lower left of Orion, this star that I'm circling right here, Sirius, the dog star. It is called that because it is in Canis Major, the large dog, one of Orion's 2 hunting dogs. And you may disagree if that looks like a dog, but the lines sort of indicate that. Here's the head, front legs, and he's standing up on his front hind legs, begging for some treats or something. The other hunting dog is marked by the star Procyon here. And so we're sort of, I'll put this whole circle up here so you can see it a little bit more easily. We're kind of going kind of a football shape, and we're going clockwise around it. So the big dog's Sirius. Let's get rid of that so you can see it more easily. And then Procyon is in a constellation called Canis Minor, the little dog. There and there. Those are its two stars. Do you see a dog there? Okay, do you see a hot dog up there? That's about all I see. But anyway, that is Canis Minor, the little dog. And then the two twin brothers, Gemini, continuing around the circle. You see the twin stars, Pollux and Castor, in the constellation of Gemini, the twins. And they're quite high in the sky. Those are two twin brothers standing side by side. These are the two twins that sailed with Jason and the Argonauts in the quest of the Golden Fleece. You see the two stick figures marking the two brothers side by side. At the very top of the winter circle, at about 6:45 or 7 o'clock or so, it's going to be almost directly overhead. The bright star, a yellowish star, indicating that it's the same temperature as the sun. In a constellation called Orion, the chariot driver, it looks more like just a pentagon shape. And this has also been seen as the inventor of the chariot. It's also a herding type of character. And then Taurus the bull, locked in battle with Orion. So his red right eye, Aldebaran, is in a V-shaped group of stars called the Hyades, the face of the bull, and his two horns going straight up, which bull's horns don't normally do, but whatever. So what has sparked Taurus's anger, and why is Taurus angrily charging Orion? Well, look at this group of stars right here. That is a group of stars. Anybody know what that is? Somebody may know the Greek name for that particular group of stars, often called the Seven Sisters or the Seven Daughters of Atlas. That's right, the Seven Sisters, also known as and Regina came up with it, Pleiades. And this is the little star group about 400 light years away from the Earth, about an average for star distances. Now, stars are much farther away. Next to the Pleiades is something that is a lot closer to us, and it is not a star at all, but a planet, the red planet Mars. Now, the red planet Mars was at its brightest last October. It was closest to the Earth in its orbit, about 35 million miles away from us, which is about as close as it gets. And it was fully lit up, just like a full moon. All of the side of the Mars facing us was illuminated, and so it was at its brightest thing in the sky, except for the moon. It's been fading ever since because it's moved to a position where it's not fully illuminated by the sun, at least the side that faces us, and we've been moving away from it. Right now, we are at about 140 million miles away from Mars, so we look smaller in a telescope, looks fainter in the sky, but still, it's an attention grabber there. About 140 million miles away. That is about 12 light minutes away. In other words, the light that bounces off Mars, comes from the sun, bounces off Mars, comes to us here on the Earth. It takes about 12 minutes to cover the amount of space between us, Mars and us. Compare that to 400 years for light to get from the Pleiades. So Pleiades are way, way farther away. And it's a good test of your vision. If you can see all 7 stars, most people can see 6 or 7. That's a good test of your vision. So wintertime constellations. And coming up in the eastern sky, already a sign of spring, which we'll especially see if we can move time ahead another hour or so. The backwards question mark, sickle shape here. It's backwards question mark of 6 stars. And 3 stars right here in a triangle. Notice the 2 of these together. Put the 2 of those together, this shape and the triangle. Do they seem to suggest some kind of animal to you? If so, what? Or maybe some of you even know what that constellation is. Kind of a symbol of spring. So put it in the chat if you know. Is it a lion? Kind of looks like a lion. In fact, it is a lion. And that is, in fact, Leo the lion. His head and mane, the star Regulus, which I am indicating right now, marks the heart or chest of the lion, and his hindquarters and tail. So if I take away those lines, you might be able to imagine that. So now let's move to the morning sky. Some interesting things there, and then I'll throw it open for general questions, certainly. So as we move time ahead, you'll notice that the sky stars rise in the east because we got the red letter E indicating they're east. Stars are rising in the east, a little stop motion. Setting in the west like the sun did earlier. But look to the north, and you see that the whole sky appears to be rotating around a star. Does anybody see? You can see, notice the stars are moving. Do you see the one star that does not appear to move? I'll put it right in the center. What star is that? Does not appear to move. It's right over the letter N, which gives you a clue what star that is. North Star, also known as Polaris, the star that's right over the north pole of the Earth. And to find it in the sky, just look for the one star that's medium bright. It's not the brightest star in the sky, contrary to what some people have been told. It's about the 50th brightest star in the sky. But there's another star pattern that you may know that will help to point your way to it. And that is in the middle of another constellation. I'll zoom in on it. It is part of a constellation, not a constellation itself, but the 3 stars in the handle and 4 stars in the bowl of the Big Dipper. So the 2 stars at the end of the bowl, see the bowl, looks like a saucepan in the sky. Those 2 bowl stars make a line that point right to the North Star. So we're a little after midnight now as we move time ahead now to the evening, to the morning hours, starting to get a little bright. A little too bright there. I won't. Look to the eastern sky. Nothing going on except a few planets. Now, these two planets, Mercury and Saturn, that we're indicating here, are a little too low to be seen. The sky is already getting kind of bright. If you're willing to wait a week or two till the end of the month, you'll notice how those planets appear higher and higher and higher at dawn. So look at it just around 6 o'clock in the morning, be able to see them. 3 planets, Mercury, Saturn, and Jupiter. So we only had 1 planet in the evening sky, but we got the 3 planets, Mercury, Saturn, and Jupiter, and appearing in the sky there. And I'm not sure if Venus is actually joining them. No, it actually isn't joining them right there. But we began the month with no planets visible before dawn. All of a sudden, we have the 3 planets, Mercury, Saturn, and Jupiter. It's kind of rare to see Mercury, and we don't get that great a view of it. So you have to have a very clear horizon to the east. Fortunately, we on the East Coast have that. We can go to a beach, look out of the Atlantic Ocean. And notice Jupiter and Saturn, though. Those are the 2 planets which, at the end of December, were closer together than they had ever been in 800 years. Well, that's the way they appeared in the sky. They've been moving apart. Now they've emerged on the other side of the sun. So that is our view of the sky. Does anybody have any general questions as we wrap things up here? So if you have any questions, please put them in the Q&A, and we'll try to answer them about what you've seen or what's going to be happening in the sky. So nothing yet. Let's zoom out a little bit here.
I don't see any questions, Chuck, but we could go back and look at Ursa Major again. Oh, we got one from Allison. How do we know it was 800 years since the last time that they were close together?
Sure. Well, we know that Jupiter and Saturn, once about every 20 years, get very close together. And we can run time back in our computers or our planetarium projectors, we used to use in the days before computers, or we can check the records, and nowhere do we have any record of those planets appearing that close together. They were about 1/10 of a degree apart. that is a very tiny portion of a degree apart. Some people probably couldn't even tell them apart. They look like a single object. That has not happened since about the year 1200 or so. So it just happened to be an extremely close conjunction. Now, these planets were not actually physically close together in space, hundreds of millions of miles apart, but they lined up so that the same line of sight, say here's Jupiter here, and here's Saturn, they lined up so that they look very close together. So my fingers are actually not close together in space, but they just look that way to your eye right now. So, any other questions?
Yes. So Regina wants to know when the next big event when planets are going to visually look close together is.
Well, throughout the year, we got several times when that's going to happen. Jupiter and Saturn are going to be moving farther apart, but Mercury's got a couple of conjunctions with other planets. The Moon, of course, as it goes around the same track in the sky that the planets appear to travel, it passes close. Offhand, there isn't anything as spectacular as there was last year, but on MOS.org, if you go to the Explore section of the MOS.org page, click on Planetarium, the tile in the upper left-hand corner has the monthly sky chart. And you can keep tabs on every month. And every month we have a feature event of the month, and there are several close passes of planets during the course of the next year. This just for various planets, but nothing really headline grabbing like the one we saw last December.
And then we have a question about how old Polaris is. I don't know if we know the answer to that.
Polaris, Polaris is actually a multiple star. We think that all the stars form together, but there are probably at least 6 members, maybe even 8 that I know about. I don't know offhand how old those stars are, but those stars are what we call main sequence stars, meaning that they are in the middle of their normal lifetimes. And those stars can last for millions, if not billions of years. I would say that the total lifetime is at least 100 million years on the Polaris system, or maybe several billion years. I don't know how far they are through it, but I don't think those are stars that are near the end of their main sequence life. So they still got hundreds of millions of years to go.
And since you mentioned main sequence, Natalie wants to know what stage of the star life cycle our sun is in currently.
The sun's about halfway through its life cycle. It formed, along with the Earth and other planets, about 4.5 billion years ago. We know this because we know this is how solar systems form. We can see this happening elsewhere, that the sun forms, that the star forms along with its system of planets. So about 4.5 billion years. The sun's got about another 5 billion years or so, 4 billion years or so, during which time it's going to be continually, slowly increasing in brightness by about and temperature. By about 1 billion years from now, it will make life on Earth probably not possible the way it is now, and then it will just keep warming from there. It will swell up to become a red giant in about 5 billion years or so, raising the surface temperature of the Earth to about 1,000 degrees Fahrenheit. And then in one or more spasms, blow off its outer layers in what we call a planetary nebula, a ring of gas. We've seen this around other stars as well.
All right. Well, I think that's all we have time for today. Thank you so much, Chuck. You can
You're welcome.
say goodbye and stop sharing your screen. Perfect.
Okay. Bye-bye, everybody. Happy stargazing.
And I will say thank you all for joining us today. We hope you learned something about what's up in the sky tonight and enjoyed yourself. I'm sorry we couldn't get to all of your questions, but we got to most of them today. So it was a good day for question answering. If you'd like to see other virtual planetarium programs or other virtual programs that the museum is offering, you can check us out on our social media channels or visit www.mos.org/mos@home. If you enjoyed today's presentation and would like to support more programming like this, please visit engaged.mos.org/welcome to support MOS at Home, and thank you to everyone who has. Today's program was produced, as Chuck said at the beginning, using the free software Stellarium, which you can find at stellarium.org. Thanks everyone for joining us today, and we hope you'll join us again soon.